Let's do the thing that everybody loves, factoring. The first type of factoring that we'll cover is common factoring. And one thing that I always say to people is common factor first, meaning that no matter what type of factoring we do, this type of factoring, common factoring, you're always going to want to try to do first before you do anything else. So keep that in mind. An example would be if you had something like 3x squared plus 6x plus 9, and I asked you, hey, common factor this. Well, you'd look at each term, and you'd see if there's a number or a variable, or both, that you could divide each term by and still get a whole number. In this case, your answer would be 3, right? 3 is your greatest common factor. It's the biggest number that can come out of each term. So you take out a 3, and what are you left with? Or in other words, divide each of these terms by 3 and write your answer here, right? Here you'd be left with x squared plus 2x plus 3. And it's very easy to check your answer because you just distribute the 3 back into the bracket, right? You multiply it out and see if you get back to your original answer. That's all you have to do to check. If I give you something like 2x plus 8, same idea. What's the biggest number that goes into 2x and 8? Well, it'd be 2. You'd be left with x plus 4, right? Nothing left in here that you can take out. If I gave you 8a cubed plus 2a squared plus 4a, you would say, well, it looks like I can take out a 2, but you can also take out an a. So what would you be left with? You'd have 4a squared plus a plus 2, right? Because if you multiply this out, you get back to this, right? 2a times 4a squared is 8a cubed. 2a times a is 2a squared. 2a times 2 is 4a. Let's do one more. If you have 4xy z squared minus 10x squared y squared z cubed, what's the largest common factor or the greatest common factor? Well, let's start with the number part, right? There's a 4 and a 10. I think I can take out a 2. Look at the x's. I think I can take out 1x because this one here only has 1x to give. You look at the y's, this y here, there's only one y to give, so I can only take out one y. You look at the z's, there's z squared and z cubed, so this one only has 2 z's to give, so the most I can take out of both is 2. So the greatest common factor is 2xyz squared. And what are you going to be left with? You'll be left with 2 for the first term, that's it, right? Because 2 times this gives you your original, minus 5 times x, y, z, right? Because 2 times negative 5 is negative 10, x times x is x squared, y times y is y squared, z squared times z is z cubed. So if you look at these two terms in here, there's nothing they have in common anymore that you can take out. That's how you know you're done. Okay, that's common factoring. Let's look at something else. Let's look at grouping. Grouping is important on its own, but it's also a key component of another type of factoring that we're going to look at further along in the video. So what is grouping? Well, an example would be if you had something like 6x squared plus 3x minus 10x minus 5. And grouping tells us that you can common factor these two terms together and then common factor these two terms together. Just do it separately. And then in the end, you might be able to common factor something out of each of those and then have a final answer. So let me show you what I mean. These first two terms, I think the greatest common factor is 3x, because then you'd be left with 2x plus 1. And with these two terms, it looks like you can factor out a negative 5, and you'd be left with 2x plus 1. Now, something that should make you smile when you're doing a grouping question like this is getting the same bracket here as you get here. See how they both contain 2x plus 1? What that means is that between this big term and this big term, they both share a common factor of 2x plus 1. That little bracket there, those brackets are the common factors. So you can now factor out that bracket, right? You can take out the 2x plus 1, and you're left with whatever was in front of them. So 3x minus 5. Now it's factored. That's the essence of grouping. We'll do one more example. Let's say we have 7x squared plus 21x plus 3x plus 9. Common factor the first two, and then you can take out a 7x. You'll be left with x plus 3. The next pair over here, the next group, you can take out a 3. You'll be left with x plus 3 as well. So again, you want the same thing here and here. We do. That's good news. So you have x plus 3 times 7x plus 3. Okay, hopefully that makes sense. And again, this isn't always going to work, but if they're giving you a question like this, it's most likely designed to work, because if you just put a bunch of numbers in here, you try to make up a question, odds are it would not work out this nicely. So most of the time they're made specifically to work out in this way. Let's look at another type of factoring though. Let's look at a simple trinomial. What is a simple trinomial? A simple trinomial is something like x squared plus 5x plus 4. And the reason we call this simple is because there's a 1 on the front of your x squared. We don't usually write it, but if there's no number there, we assume it's a 1. If that's the case, we call it a simple trinomial, and all you have to do is use the sum product method. Okay? And the sum product method is really nice. All you have to do is look at the last number and say what multiplies to the last number, so 4, and adds to the middle number, 5. Specifically, I want two numbers that are going to do this. I want two numbers that multiply to 4 and add to 5. So if you think about it for a sec, you think of all the numbers that multiply to 4. You could have 2 times 2, or you could have 4 times 1. And you realize, oh, 4 times 1, that adds to 5. So 4 and 1 are your special numbers. And so to factor this, all you have to do is write x plus 4 and x plus 1. Is put those numbers in there. And you're done, right? If you want to check your work, you could FOIL this, and you would get back to your original answer, right? In fact, if you FOIL it, you might see why these rules exist. Because when you expand this, your last step of the FOILing is 4 times 1, right? The two numbers multiply to 4. And also when you multiply it out, you'll get 4x plus 1x, and they add together to 5x. That's why they have to add to 5. So if you were to FOIL this out, you would see very clearly why we're doing this, right? Somebody worked that out in reverse, came up with these rules, and now we're able to factor this without having to give it too much thought. We just have to remember these steps. So let's do another example. Hopefully we can get comfortable with this idea. So x squared plus 7x plus 12. Again, I want two numbers that multiply to 12 and add to 7. So you think of all the numbers that multiply to 12, you could have 12 and 1, 6 and 2, we're getting close, right? 4 and 3, I think that's it, right? 4 and 3, they add to 7, multiply to 12. So your answer here would be x plus 4 and x plus 3, just like that. There's nothing more to it. We'll do one more. Let's say we have x squared minus 15x plus 26. So I want two numbers that multiply to 26 and add to negative 15. So again, I like to start by listing all the numbers that multiply to the first number, because if you start by thinking of all the numbers that add to a particular number, you're going to be here all day, right? There's an infinite amount of numbers, right? An infinite amount of combinations that will add to negative 15, but there's only so many whole numbers that multiply to 26, right? You could have 26 and 1. You could have 13 and 2. Oh, and this is interesting, right? Because 13 plus 2 is 15. They have to add to negative 15. So what if they're both negative? They'd still multiply to a positive, but they'd add to negative 15. So you got to look at the signs, right, and use that as clues. So negative 13 times negative 2 is 26. Negative 13 plus negative 2 is negative 15. So your numbers are negative 13, negative 2. You just write them in here like this. And that's your final answer. Let's look at factoring trinomials using decomposition. So you use this when we have a trinomial that is not simple, something like 2x squared plus 11x plus 5. Right? The number in front of the x squared is not a 1, so we can't use that old method. Right? You can't just say what multiplies to 5 adds to 11. We can't do that. It's more complicated. What you do first is 2 times 5. You do the first number times the last number. So 2 times 5 is equal to 10. Now this next step is going to look familiar. Now you ask yourself, what multiplies to 10 and adds to 11? So a very similar step, right? Well, if you think about this for a second, you realize, oh, 10 times 1 is 10, and 10 plus 1 is 11. So 10 and 1 will be your special numbers. But you don't just plug them into a bracket like we did before. What you do here is the reason we call this decomposition, because the middle term is going to decompose. Let me show you what I mean. you'll have 2x squared, and then the 11x is going to split up or decompose into 10x plus 1x. You don't have to write the 1, but plus x, and then plus 5. So that middle term breaks up. That's why they had to add to the 11x. So now you common factor by grouping, right? Remember how I said you have to know how to do grouping because it's going to come back to be important in another type of factoring? This is what I was talking about. So these first two terms, you can factor out a 2x, and you'll be left with x plus 5. The next two terms, you can only factor out a 1, and you can write the 1 if you want, but you don't have to. And then you're left with x plus 5. And remember, the goal is to get the same thing here and here in these two brackets. You want x plus 5 and x plus 5. So now that they're the same, that's good news. You can say, all right, my final answer is x plus 5 times 2x plus 1. And now that's your final answer. Let's do another one. Let's say we have 3x squared plus 8x plus 4. So 3 times 4, first number and last number multiplied, is 12. So we want two numbers that multiply to 12 and add to 8. So think of all the numbers that multiply to 12. 12 and 1, 6 and 2, 3 and 4. I think 6 and 2 will do the trick, right? Because 6 plus 2 is 8, and 6 times 2 is 12. So here's where we do our decomposition, right? 3x squared plus 6x plus 2x. We split up that 8x into those two terms, and then plus 4. Factor by grouping. 3x, x plus 2, plus, you can take out a 2, and you're left with x plus 2. Very good. We get the same thing. X plus 2, 3x plus 2. And that's your final answer. Now let's talk about perfect square trinomials. Perfect square trinomials. A perfect square trinomial is a special type of trinomial that kind of fits into this pattern here. It looks something like a squared plus 2ab plus b squared. If you can write a trinomial in this pattern, it qualifies as a perfect square trinomial. And if it is, then when you factor it, you're going to get a plus b times a plus b, which you can just write as a plus b squared. So if you identify your equation as fitting this pattern, you can just factor it like this. You don't have to do any of the other work. You don't have to do the sum product method. You don't have to do decomposition. You just skip to the end like this. Okay? But it has to fit this pattern. So let's look at an example where they fit the pattern. So let's say you have 4x squared plus 12x plus 9. Well, I could write this as something squared, right, like a squared, and then the last term is something squared, right, b squared. And then the middle term, I'm asking myself, is it possible that I could write the middle term as 2ab? Well, if I write 2, a is 2x, b is 3, is this 2ab? Is that equal to 12x? Well, 2 times 2 times 3, that's 12, and you have an x, so 12x. So yeah, you could write this in the form a squared plus 2ab plus b squared. It does fit, right? This does fit the form. And so because of that, when you factor it, all you have to do is write a, which is 2x, plus b, which is 3, squared. That's all you have to do to factor. Now, if you wanted to use decomposition, you absolutely could, right? You could do 4 times 9, you get 36. You'd say what multiplies to 36 and adds to 12. You'd find your numbers. I think it's 6 and 6. And then from there, you would decompose the 12x into 6x and 6x. You would do your factoring by grouping, and you would eventually get the exact same answer. You can try that on your own if you want to see that. But if not, this is all you really need to know. And so you might be asking yourself, how do I identify this quicker? Because I can't be checking all the time, right? Well, the key to this is if you think, okay, what's the square root of 4? Well, it's 2, right? Like whenever you see 4, you should be thinking, okay, 4 square root of 4 is 2. When you see 9, you think, oh, 9 square root of 9 is 3. Well, 3 and 2, those are both numbers that go into 12. In fact, if you do 3 times 2, you get 6, which is half of 12. And that's really the trick here, right? Because this middle term is 2 times a and b, where a and b are the roots of those first and last terms. So if you see a 4, you say, oh, square root of that's 2. You see 9, square root of that's 3. 3 times 2 is 6. If that's half of this number, which in this case it is, that makes this a perfect square trinomial. And so that's probably the best way you can go about trying to figure out if it's a perfect square trinomial. Some people choose not to remember this and they just decide to factor things using sum product method or decomposition. That's also absolutely fine because you're going to end up with the same answer. it's just something interesting that you can take a look at and use to help you factor these things quicker, but completely up to you if you want to focus on it or not. But it's good to know because you could have a test question that says specifically, identify whether the following is a perfect square trinomial. And in that case, you're going to need to know what it is exactly. So definitely take a look at this. So let's look at another type of factoring. This one is called difference of squares. Difference of squares. If you're confused as to how we're going to identify these, don't worry because it's in the name itself. When you think of a square is a term that you can take the square root of, right? Like x squared, for example, that's a square. And difference refers to subtraction, right? So a difference of squares is just one square minus another. So an example of that would be something like x squared minus 4. These are both squares because we're capable of taking the square root of each one and getting a nice whole number or a term, right? And it's a difference because we're subtracting them, right? If you add two numbers, it's a sum. If you divide, it's a quotient. If you multiply, it's a product. And if you subtract, it's a difference, right? So this, if you just look at it, you'd say, oh, it's two squares being subtracted. Yeah, that's why it's a difference of squares. So all we have to do to factor this, you're going to like this, is you set up two brackets. You do the square root of x squared, which is x. Put it there and there. Square root of 4 is 2. Put it there and there. You do one addition, one subtraction. Doesn't matter which is which, right? Those brackets can be flipped around. Doesn't matter. That's all you do. Let me show you another one. X squared minus 9. You factor it, you're going to get x plus 3, x minus 3. Right? Because 3 is the square root of 9. That's all you have to do, right? And the reason it works out so nicely is because if you were to FOIL this, the first term you get is x squared. The last term you get, 2 times negative 2 is negative 4. And then you say, what happened to the middle terms? Well, x times negative 2 is negative 2x, and 2 times x is positive 2x. So those two terms end up canceling each other out. So this is like a trinomial that's missing its middle term, right? It's missing its term that's like a number times x. And that's because of the plus minus. It cancels out. So if you want to FOIL this, to check your work, you'll see exactly how it works out. Let's do another example though, because these questions can get trickier, right? You could have something like, I don't know if this is trickier, it might be kind of a trick question because you might forget that the square root of 1 is 1, right? So your answer here would be x plus 1, x minus 1, right? Another one would be x squared minus 16. You'd have x plus 4, x minus 4. Not too hard. But what if they gave you something like x to the exponent 4 minus 16? What is this? Well, you set it up the same way. You say, what's the square root of x to the 4? Well, it's x squared. So I put x squared there and there. And then what's the square root of 16? Well, we know that's 4, so I put plus 4 minus 4. Right, so now you're done. You've factored the difference of squares. Except you can actually go further, because if you notice, the second bracket here is its own difference of squares, right? Inside that bracket, you have x squared minus 4. That itself could be a question, right? They could just give you that. So we can actually factor this further. The first bracket stays the same because the first one's not a difference, it's a plus, right? It's a sum. So we can't factor that. But the second one you could factor, right? And it would become x minus 2, x plus 2. Then you'd be done. Let's look at another one. What if you have 4x squared minus 9? Okay, well, now what's the square root of 4x squared? Well, it's 2x. So you put 2x there and there. Square root of 9 is 3, so I'll put plus 3 minus 3. Just like that. Let's do another one. What if I have 9x squared minus 16y squared? So now I'm introducing another variable. Well, it's the same process, right? What's the square root of 9x squared? 3x. What's the square root of 16y squared? 4y. So you get 3x plus 4y and 3x minus 4y. What if I gave you this one? What if I said 16x to the 4 minus 81y to the 4? Same idea. Square root of 16x to the 4 is 4x squared. And then 81y to the 4 would be 9y squared. And you write it over here as well. Except we subtract in this one. And now, just like that question we did a couple questions ago, we would say this isn't done because this is another difference of squares inside this bracket. So you always got to check and see if you're done. So I could say, all right, 4x squared plus 9y squared. That one's the same. But then this one I can factor again. So you'd have 2x plus 3y and 2x minus 3y. Now you're done, because this is the only one with subtraction, but they're not squares, so you can't factor that any further. Hopefully that was enough examples to get you comfortable with the idea of difference of squares. There's one more type of factoring that I'll show you, and this one's probably the least common. So this is called sum or difference of cubes. Sum or difference of cubes. So if you have something like a cubed plus b cubed, or if you have something like a cubed minus b cubed, you can actually factor both of these. And the way I would recommend doing it is just by remembering the equation for this, to be honest. So a cubed plus b cubed, that's just equal to a plus b times a squared minus ab plus b squared. And a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. It honestly just comes down to that. You have these equations, and if you can find, what numbers are a and b, right? You just follow the pattern, and that's how you factor these. That's honestly the most common way that this is done. So if I gave you an example, and I told you we have 2x cubed plus 128y cubed, you'd have to identify what a and b are, right? And actually, even before that, if you recall, at the start of this video, I said, what's the first thing you do? Well, you common factor first. It's going to make your life a lot easier. So see if there's a common factor, and in fact, for this one there is. You can take out a 2. If you take out a 2, you're left with x cubed plus 64y cubed. Right? Now we say, all right, pretend that 2 is not there. Just leave it on the outside and deal with what's on the inside. What's a? Well, a is x, right? A cubed, you have x cubed. What's b? Well, b would be, what's the cube of 64? Well, the cube of 64 is 4, right? And then you have y, so 4y cubed, right? Because 4 times 4 is 16, times 4 is 64. So your a value is x, and your b value is 4y. So we just follow this pattern, right? We say a plus b, so x plus 4y, times a squared, so x squared, minus a times b, so I'll multiply these two together, and I'll get 4xy, plus b squared, so 4y squared, which is 16y squared. And write it like that. And that's your final answer. We can do the same thing if there's a difference, right? If they're being subtracted. So let's say we have y cubed minus 8, right? That's like saying, okay, so y is the a value because it's y cubed minus 2 cubed, right? So a is y and b is 2. So your final answer, you follow the pattern, a minus b, so y minus 2, times a squared, so y squared, plus a times b, so 2y, plus b squared, so 2 squared, or 4. And that's your final answer. This is probably the least common type of factoring you're going to need to know, but it's a good thing to keep in your back pocket, right, these equations. Because the reason we learn so many different types of factoring, at least for now, is as it relates to quadratics, right, and quadratic equations. And for quadratic equations, usually you're only dealing with squares, right? Like a quadratic equation is going to have an x to the exponent 2. So this difference or sum of cubes isn't going to be the most useful right now, although it will become useful maybe down the road in other classes and in other units. So this is the least common, so I would say get very familiar with common factoring, simple trinomials, using decomposition, difference of squares, absolutely, and familiarize yourself as well with perfect square trinomials, but this is probably the last one I would focus on, but definitely make yourself familiar with it.